Hi there. Thank you for finding our poster on infrequent earthquakes in southern Malawi. So my name's Jack Williams, and this poster is essentially presenting some results coming out of the Prepare project. So this video will just kind of briefly give some context to our project, and in particular, why we're interested in earthquakes in the East African Rift. And it's quite clear that when you look at the three components of risk, hazard, exposure, and vulnerability, then seismic risk in the East African Rift is increasing quite quickly now, driven by population growth, which is driving exposure, and the proliferation of seismically vulnerable building stock. So it means that we need to get the hazard component of risk really well constrained, because even a moderate-sized earthquake there could cause quite significant loss. So this is where the Prepare project comes in. We're a team of earth scientists and engineers in the UK based at Cardiff University and the University of Bristol. And also, very importantly, we've been collaborating with partners in Malawi, particularly in the Geological Survey and the University of Malawi. And although you can see our project has a quite contrived acronym, the point it's trying to make is that the best way of dealing with natural disasters is through preparing for them in advance as opposed to reactively responding to them. So you can see there's quite a complex kind of framework with how this project all comes together. But today, mainly talking about hazard, obviously, but with a point that it links to dealing with all parts of seismic risk. And when we consider seismic hazard in the East African Rift, then most studies have just kind of used the instrumental record of earthquakes doing probabilistic seismic hazard analysis. But the earthquake record in East Africa is quite short, and also the rift itself is extending quite slowly. The geological faults are very long, and we think they're likely to be locked. So it's likely that they eruption quite infrequent earthquakes that are just not captured in this quite short record. And the effect of this on seismic hazard assessment was investigated a few years ago in a paper by Hodge et al. 2015. And so what you're seeing here is a seismic hazard map for Malawi based on just using the instrumental record of earthquakes, and a map here showing one that considers faults as well. And you can see that just using some basic geologic and geodetic data to constrain how the faults might rupture in earthquakes changes our hazard assessment quite a lot. So it's kind of showing us that there's a need to include kind of fault, geologic, and geodetic data when considering seismic hazard assessment in the rift. But obviously the active fault mapping there is still not very complete, and there's very few kind of paleoseismic trenches or measured on-fault slip rates in the rift. So in the next part of the poster, in the next video, I'll be talking about how we addressed that in southern Malawi.